Hello viewers, you're welcome back to physics classes today. Today we'll continue our studies on the variables of motion and we are looking at this time around what happens in an inclined plane. We have talked about what happens for force as a constant. We have talked about what happens for force as an explicit function of time. Today we are discussing the simple case of force of an inclined plane. Now, when you have an inclined plane and motion is supposed to go through and through the plane, what happens to the variables of motion? You just watch, let's play around with it. Thank you. Now, looking at this plane with the force upward and force downward, giving you the y-axis, and the force on the normal to this plane, giving you the x-axis, you would agree with me that sine theta for this plane will be equal to Fy all over W, which is the weight of the body. Now, Fy will be equal to W sine theta. Weight alone, which is W, is mg, so Fy is equal to mg sine theta. Now, similarly, for Fx, you're going to have that it is mg sine cos theta. Okay? Now, having taken this, you would agree with me that the total force on this plane is going to give you F minus Fy, and that will give you MA x. This is the total force, and it's equal to this. And for from here we can proceed to say that F minus mg sine theta is equal to MA x. Then we keep that in mind, and then we take that Fc from this plane, you look at it, minus Fx will give us 0. This would simply mean that Fc minus mg cos theta is equal to 0. And that means Fc is equal to mg cos theta. But F is equal to mu Fc, which is equal to mu r. You have this, then we replace this in our equation. So bring this equation down here. We have that mu Fc minus mg sine theta will give us MAX. Name this equation beta. Now, then we can now see that from beta, Fc is equal to mg cos theta. Therefore, we can now see that mu into mu times mg cos theta minus mg sine theta is equal to MAX. This would mean that mu mg cos theta minus mg sine theta is equal to MAX. This, if we factor out mg, we're going to have that mg into the bracket of mu cos theta minus sine theta all equal to MA. This would imply that, let's write it clearly please, mg into mu cos theta minus sine theta all equal to MAX. Now, if we have this cancels this, then we have that A of AX is equal to G into mu cos theta minus sine theta. But AX is equal to the Vx all over the t. Then we can now have that the Vx is equal to Ax dt. If that is the case, we're going to have that x is equal to v naught x plus integral ax dt. We now substitute the value of ax as we have in, call this equation alpha. Now, so we can now see that substitute for the values of ax as in alpha. Therefore, v of x, vx will be equal to v naught x plus integral of g mu cos theta minus sine theta. If this is the case, then we have v naught x plus g constant, this, and then we have mu cos omega t minus sine omega t all dt. Then we have equal to v naught x plus g. The integration of this gives us that mu sine omega t plus cos omega t all over omega and then we have equal to v naught plus g all over omega into mu sine omega t plus cos omega t. But v of x is equal to the x all over the t. If this is the case, we're going to have that dx is equal to vx dt. We're going to have x is equal to x naught plus integral vx dt. Then we can now have that substitute for vx as above, we're going to have x is equal to x naught plus integral of v naught x plus g all over omega bracket open mu sine omega t plus cos omega t dt. This will be equal to x naught plus v naught xt plus g all over omega t omega into minus mu cos omega t all over omega. Then we have plus sine omega t all over omega. This will be equal to x naught plus v naught xt plus g all over omega square all into the bracket of minus mu cos omega t plus sine omega t. Therefore, finally, we can have that our x is equal to x naught plus v naught xt plus g all over omega square all into the bracket of sine omega t minus mu cos omega t. Thanks for watching today's episode of Physics Classes with Ode. I hope you enjoyed it. Please subscribe to our channel for more videos. Thank you.